The reason we split up this flip into two pieces is one, because the phone rang in the first part, but also it seemed to me to make more sense to put the two-step problem in a separate flip, because there's some students who will be okay with one-step problems but would just struggle with the two-step. So we decided to put it separately. A common two-step problem is this. If you're asked to go from grams of something to atoms, or of course, backwards, from atoms to grams. I'll be honest with you, this doesn't happen half as often as this. Needing to know how many atoms are in a given number of grams. So what we're going to do is, we're going to start with grams to atoms, and then if we need to, we can add a flip later going from atoms to grams. But just as you saw in the previous flip, or if you didn't watch it, once you go one way, it's pretty easy to figure out which way you go. So if you remember in class or in the last flip, you used one of these conversion factors or the other. In this case, with our two-step problem, you're going to use both of them. All right, and you just need to figure out which ones you'll need for which particular problem. So what we're going to do is we're going to go ahead and get started and write down what we're given. And what we're given in this problem is 12.1 grams of lithium. And I like to draw a real long railroad track because this guy is going to take some room, okay? Now, the first thing we need to do is find the conversion factor that uses grams. And this one just has moles and atoms, and this one has moles and grams. So we're going to use the second group here. And now we need to ask ourselves, do we need grams on the bottom or do we need grams on the top? I contend we need grams on the bottom so they'll cancel out and we're left with moles on top. And then from moles we can use the other one. So when in doubt, go to moles. And that's true pretty much all semester. So what we need to do in order to go from grams to moles is we need to find our molar mass. And if you remember, that's on the periodic table. Coming over here on the periodic table, we look at lithium here, it's number 2. Lithium is 6.941 grams per mole. 2 places past the decimal is going to be okay with me. So I'm going to put my grams, 6.94 grams of lithium. Keep in mind, putting how you're measuring it and what you're measuring, teaspoons of baking soda, cups of flour, that type of thing. And then 1 mole of lithium. Now let's check and see if everything cancels out. Grams will cancel out, 1 on the top, 1 on the bottom. We're left with moles on top, and I think that's a pretty good start. But if you remember, the problem asks us to go to atoms, not to moles. So we've got to add a step. And if you look, we have a nice conversion factor here that's going to help us go from moles to atoms or atoms to moles. So the question is, which one do we use? Is moles going to be on top or the bottom? Moles on top here, we're going to need it to go on the bottom here to cancel out. So you need to remember that 1 mole of lithium will be 6.02 times 10 to the 20, that's a 2, 3 atoms of lithium, all right? And so now all we need to do is plug and chug. One of the things I do want you to understand is, as this number goes with atoms, this big number will never be moles. It's always going to be atoms. And so these conversion factors, while they can flip, if you see this number always goes with atoms, and this molar mass will always go with grams. You can't flip that, and a lot of students want to. All right, so now what we need to do is we need to multiply 12.1 times 1, which we'll skip, times 6.02 times 10 to the 23, and then divide by 6.94, and you can divide by 1 if you want to, and then hopefully we'll get our answer. And you need to realize, if we're going from grams to atoms, we're going to get a big number. There are going to be a lot of atoms in, however many grams we have. So, moving this up, turning our calculator on, clearing it out, we're going to start with 12.1, and that's in grams. We're going to multiply by 1, imaginary, times 6.02. Don't forget your second function key. The other thing you can do is put a shortcut key in here, and I can't remember how to do that in this calculator, but anyway. So you've multiplied across the top. Sometimes I press enter. Then I like to divide through on the bottom. It really doesn't matter. Order of operations, you're in good shape. And as you can see, that's 1.0495 blah, 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 times 10 to the 24. A big number, just as we had anticipated. So I like to write 12.1 grams of lithium is equal to 1.05 times 10 to the 24 atoms of lithium. Now, if you think about it, the two-step problem going from atoms to grams is just this exactly backwards. And you should be able to set that up and try that, starting with this number, and then when you do all the math, you should get right back to where we started with 12.1 grams of lithium. I hope this is clear as mud. Cut.